In this video, we will graph an absolute value function on a Cartesian plane from the rule in simplified standard form. Before we start, let's review the properties of the absolute function that will allow us to draw it. The rule for an absolute value function in simplified standard form is f of x is equal to a times the absolute value of x minus h plus k. An absolute value function is composed of two rays which form a v. The vertex of the function has coordinates hk. Each ray is a reflection of the other with respect to the line x equals h. The sign of parameter a determines the direction of the opening of the function. If a is positive, the function opens upwards. On the other hand, if a is negative, the function opens downwards. In other words, by exploring the three parameters of the function, we can quickly make a sketch of the graph. Let's look at an example in more detail. We want to graph the function f of x is equal to negative 2 times the absolute value of negative 3x plus 9 plus 12. Since the coefficient of x is not equal to 1, the rule is not written in simplified standard form. We need to remove a greatest common factor. Now we have the function in standard form, but we can simplify this further using the properties of an absolute value. Basically, we want to get the negative 3 factored out of the absolute value bracket. When we have a product inside an absolute value bracket, we can write this product as the multiplication of two absolute values, which gives the absolute value of negative 3 times the absolute value of x minus 3. Next, we know that the absolute value of negative 3 is 3. Finally, negative 2 times 3 is negative 6. The simplified standard form is therefore f of x equals negative 6 times the absolute value of x minus 3 plus 12. Remember that parameters h and k give us the coordinates of the vertex and that the sign of a determines the opening of the function. So in order to place the vertex at the point 312, we will scale the x-axis by multiples of 3 and also scale the y-axis by multiples of 3. We plot the vertex and sketch the following graph, where the opening of the function is downward since a is negative. Now let's calculate the value of some points to get a more accurate graph. We can start by calculating the y-intercept, or the value of f of 0. We replace x with 0 in the rule. We perform the calculation while respecting the order of operations, which means we calculate inside the absolute value brackets first. 0 minus 3 is negative 3. The absolute value of negative 3 is 3. Negative 6 times 3 is negative 18. Finally, negative 18 plus 12 gives negative 6. We have found that f of 0 is equal to negative 6. We can plot the point 0, negative 6 on the graph. Next, we draw the ray that begins at vertex 312 and that passes through the point 0, negative 6. To draw the other ray, we need a point on that ray. To find one, we have two possibilities. We can choose a value of x on the other side of the vertex, for example, x equals 4, and then calculate the corresponding y value using the rule. Or, if you recall, the two rays are symmetrical with respect to the axis x equals h. So let's go with this option. The point we just plotted, 0, negative 6, is situated 3 units to the left of the axis of symmetry and has a height of negative 6. We can therefore plot a point with the same height, but situated 3 units to the right of the axis. The coordinates of this point are therefore 6, negative 6. We're done. But we observe that our function has two zeros, which is not always the case. To calculate them, replace f of x with 0 and isolate x. Begin by removing the term positive 12. We get negative 12 equals negative 6 times the absolute value of x minus 3. Then, we divide by negative 6, which gives 2 equals absolute value of x minus 3. We are at the point where we need to remove the absolute value brackets. Be careful. They cannot be removed as if they were just simple brackets. In fact, we must consider two cases. Either the expression in the absolute value is positive or it is negative. In our example, this means that the algebraic expression x minus 3 is equal to either 2 or negative 2. In the first case, we end up with the equation 2 equals x minus 3. In other words, we just leave out the absolute value brackets. We solve the equation and find that the first solution is x equals 5. The other equation to solve is negative 2 equals x minus 3. The answer is x equals 1. So, there is a 0 at points 5, 0, and 1, 0. I hope this video has helped you understand how to graph an absolute value function on a Cartesian plane. If you're given the graph of an absolute value function and you are looking for the rule, we have 3 videos for you.